Okay, this is homework 1, problem 1. We are going to find the cross product, or we're going to find the normal vector to this plane that goes through these 3 points. To do that, we're going to use the cross product, and one of the properties of the cross product is that the resultant vector from a cross product is always normal to both, or is always perpendicular to both vectors that go into the cross product. So what I'm going to do is I'm going to look at 2 different vectors that are in the plane, take their cross product, so it'll get me a vector that is perpendicular to the plane. Then I'm going to normalize it by dividing by its magnitude. So the 2 vectors that I'm going to look at in the plane are going to be these 2 vectors. So we'll call this v21 is the vector going from P2 to P1, or going from P1 to P2, and the other vector we'll call V31 is the vector going from P1 to P3. And so the math here is fairly simple. V21 is equal to P2 minus P1, which is just going to be the difference in these 2. So that's minus AX positive AY 0. V31 is vector P3 minus vector P1, which is going to be minus AX 0 AZ. Now I take the cross product of these 2 vectors. So V21 cross V31. And the way I can do that, right, is looking at the determinant of the matrix made up of the V1 here and the V21 here, the V31 here. And so this one is going to be positive AY AZ I hat. So that's this way. And the other I hat is going to be from 0, 0 back to I hat. And so the I hat is going to be a positive AY AZ I hat. The J hat is going to be the J0, so that one doesn't go, and then minus AZ A minus AX. The 2 minuses make a positive, so this will be AX AZ J hat. Plus the final will be the K hat. The K hat will be minus AX 0, then minus negative AX times positive AY, so the minus and minus make a positive again. So AX AY K hat. And so this is going to be my normal vector. This is not yet a unit vector. To get a unit vector, we need to take its magnitude. The magnitude of this normal vector is going to be the square of each of the components, the sum of the square of each of the components, and then their square root. So the square root of AY squared, AZ squared, plus AX squared, AZ squared, plus AX squared, AY squared. And then finally, the unit vector normal to the surface is going to be n divided by n hat, or n divided by the magnitude of n, I should say. N hat is n divided by the magnitude of n, which is AY AZ I hat plus AX AZ J hat plus AX AY K hat divided by the square root of AX squared AZ squared plus AX squared, or AY squared AZ squared AX squared AZ squared plus AX squared ay squared. That is the solution to problem 1.